motion, looking at motion today. I was just going up and down, seeing going up and down. I remember we are looking at motion, a very interesting topic to look at today. Motion. Now, what is motion? What is that motion is? We say that motion is the change of position of the body from one point to another. That's motion. You saw me, I came out, I was just walking up and down, moved from here and still reached here. Bring up, that's motion. It is just the change of position of the body from one point to another. It is the change of position of the body. And in the course of motion, time is involved. Because as the body changes from one point to another, there's also the change in time. Yes, there's also a change in time. And so we say that motion is the change of what? Of the position of the body. So if I will take note of that, very important. And move on. Change the change in the position of the body from one point to the other. That's what motion is. Now, basically, in the study of motion, we have four major types of motion. Four major types of motion. We have the translational motion, we have the rotational motion, we have the random motion, and we also have the words, the oscillatory motion. These are the four basic types of motion: the translational motion, the rotational motion, the random motion, and then the words, the oscillatory motion. So we will now take notes on how to study each of them properly. And the first thing we look at is the translational motion. Now, when we define translational motion, now, if I walk from here to here, as you see me do, I do not rotate when I was walking from here and I just reached here. Did I rotate? I didn't rotate. I just walk from here to. That's an example of a translational motion. It is a motion of the body that the body possesses as it moves from one point to another. It is a motion of the body while it moves from one point to another without rotating. It is the motion of the body while it moves from one point to another without rotating. That's what we call the translational motion. So if I take note of that, say that motion of the body, which moves from one point to the other without rotating. It moves from one point to the other, and it does not rotate. Move from one point to the other, and it does not rotate. It just moves from a fixed point to another fixed point. That's what we call the translational motion. And the translational motion has examples. We have examples of the translational motion. Now let's take note of the examples of translational motion. Let's just take note of it. So examples of translational motion. Translational motion. And the first example of translational motion that I love to write is the motion of a ball running from point A to point B. That's the motion. You run from point A to point B, a translational motion. All right. Now, these are further examples. The first one, the one of butterfly, which moves from one anther of a flower to the other. One anther of a flower to the other. That's what we call a translation, an example of a translational motion. A butterfly moves from one point. You know a butterfly from one point in a flower to another tree. It can move from a tree, it can move from an anther of a flower to another. So that's the translational motion. Just move. It can you see another example in football. Football soccer, a moving one, as it moves from if I play football, as it moves from one point to another. That's an example of what? Of translational motion. Another type of motion that we look at is the rotational motion. That's another type that we look at. So what is the rotational motion is? So this is the motion of a body that moves in circles. That moves in circles. We can say that it moves in circular form. Move in circular form. That's what we call rotational motion. And so another name for rotational motion is the circular motion. So another name for this rotational motion is what? Circular motion. So let's take note of that. Motion that moves circles. That's rotational motion. Now let's take examples of that. Examples of rotational motion. You see them daily. All this rotational motion, you see them daily. You see the wheel of a car. The wheel of a car. The car moving. If you look at the wheel rotates. That's the rotational motion. And also the revolving movement of football. Back to that football. So the question can still come that if football possesses both translational motion and what? And rotational motion at the same time. Yes, because as it moves from one point to another, the motion which it undergoes is rotational motion. As it translates from point of a player to another player, it actually rotates. So this is a clear example of rotational motion. So let's take note of that. All right. So the first one, the motion of the moving wheel of a car. The moving wheel of a car. You know that the wheel of a car, the wheel of a car is rotating. So the motion of the moving wheel of a car is actually rotational motion. We also know the rotational movement of the football soccer. So the football soccer at that case, also perform translational motion and also perform what? Rotational motion. Now, we also note the motion of the what? Of the blade of the fan. The motion of the blade of the what? Of the fan. That's an example of what? Rotational motion. So it's not only this to also have the blade of a fan. When you see the blade of a fan, it actually rotates. It rotates. That's an example of rotational motion. Now we also have another part of motion, which is the random motion. The random motion. What is this random motion? You see that the random motion is the motion of the body that moves disorderly, unorganized, and haphazardly without no preferred direction. That's what we call a random motion. It moves disorderly, unorganized, haphazardly, without no preferred direction. That's a random motion. So let's take note of that. So you see that this is the type of motion that moves disorderly, unorganized, and what? And haphazardly, without no preferred direction. It does not have any preferred direction. That's what we call a random motion. It does not have any preferred direction. So this is the random motion. It has types. Random motion has examples of it. We see the examples every day. One of the examples of random motion is the motion of smoke, the movement of smoke. Smoke particles, dust, smoke particles. Can somebody come and bring dust, smoke particle, mean the smoke, not the dust, smoke. When you see smoke moving, smoke does not move in a straight form. It moves randomly. It does not also move in a circular form. It moves randomly to show that that's a random motion. It does not have direction. It moves orderly. That's what we call an example of random motion. Another example, if you take a powder part, when you say powder, you take a powder, you this girl, you are washing up, you are looking at me now, you are taking powder to rub it in your body, on your face. That powder that you have now, the powder will not decide one day and say, I want to move in a circular form. No, it moves without direction, disorderly. That's what we call what? Random motion. That's an example of random motion. Those are dust particles. When you heat dust, when you blow up dust, dust particle is an example of what? Of a random motion. So let's take note of the examples of what? Random motion. All right, so these are the just a few examples of that. The movement of smoke, the movement of smoke, yes, is an example of what? Of a random motion, the movement of smoke. We also have the motion of dust, the motion of dust. Dust, when you spray dust, an example of that can still be a cosmetic powder. When you just, bring it together in your palms, it actually spreads, scatters. That's a random movement, and that's a random motion, an example of random motion. Particles suspended in the air, when you spray dust in the air, suspended in the air, it moves haphazardly. Now we have the Brownian motion. The Brownian motion. Now we know the Brownian motion is it's a motion studied by Robert Brown around uh, 1870, around that period. The German scientists studied the Brownian motion, the evidences of matter inertia. That's Brownian motion, one of the valid evidence of matter inertia. Robert Brown studied it, and when he studied it, he studied it with him suspending some particles in water. We suspended particles in water which moved in zigzag direction. That's pollen grain particles. It moved in zigzag direction. And at the end of the day, we termed it based on its name, Brownian motion, one of the evidences of the movement of existence of matter inertia. But that's by the way, we're not looking at that. We're not looking at that. Now, Brownian motion is an example of what? Of random motion. It's actually moved in zigzag direction. When it suspended the pollen grain in the water, to move in zigzag direction without preferred direction. So I can still call a random motion a zigzag motion. It moves without a direction. It's moved zigzag. So that's for that random motion. Now finally, I told you we have four basic type of motion. Finally, we have what we call the oscillatory motion. Oscillatory motion, which can also be called the periodic motion. The oscillatory motion. Let's take note of that. All right. So call this the oscillatory motion. So it is the motion of a body. It is the motion of a body that moves to and fro. It moves to and fro. Reversing its direction. It reverses its direction and returning to its original position. After it reversing its direction, it will still return to its original position. That is what we call what in oscillatory motion. It's a very simple motion that you actually see every day. The motion of the hand of a clock. When you shake your clock now, just shake your clock, you see the place, both the longer hand and the shorter hand is. And when you look at it, when you go out and come back in the next interval, you see that it will shake. But when you come back by this time tomorrow, you actually see that that time is still there, as returned back there. Now, this is what we call oscillatory motion. It moves to and fro steadily. It moves to and fro. Your 24 hours, so clock needs 24 hours, or your 12 hours clock. After you move to and fro, it will still return back to its initial position. Another simple example is the movement of the earth around the sun. After the move to and fro, after the revolution, it is still return back. That's why we have the day and night period in the surface of the earth. And we also have a similar example, practical example, in your simple pendulum. As you suspend the pendulum, it will move to and fro. And after a long while, it still return back to the center at the point it was displaced. It still return back to the point it was displaced. Now, these are just few examples of what oscillatory motion. That's why it can still be called a periodic motion. It occurs regularly depending on the time interval. That's oscillatory motion. Now let's take note of the examples. All right, so this is an example of what? Oscillatory motion. And so far, so we have studied motion. It is a topic that when you have finished watching it, you need to go again and still look at it for proper understanding if you wish to. But this is just the first part of motion. That's why it's motion one. Raise for motion two. So we'll be looking at the basic concept of speed, distance, displacement, acceleration, velocity, the uniform velocity, and the rest. A lot of them. So just want you to brace for that topics. Motion two. I still remember to